Welcome to Ask and Learn.
This problem is essentially a repeat of the previous problem. So we have the same system, and again, we've just basically replaced one of our unknowns, or swapped out an unknown. So in this case, we don't know what the magnitude here is, this magnitude of this applied force. But what we want is for the y component of the reaction at C. So this guy here, we want that to be 0. So instead of having this known and this unknown, we know what this is and we don't know what that is. And so the analysis is exactly the same. The equations are the same, and we just have a different unknown in our equations. But we can do the same algebra. And in that case, what we'll find is f5y, if we just solve for it in terms of f4, is 318 minus 0.472 f4, and these are in pounds. And so we want this to be 0, so we can solve for f4, and we find that f4 should be 674 pounds. So in the previous problem, it was only 250 pounds. So we had, in that case, we had this value here. So we actually need to increase that load a lot to get this component to be 0. And because that, let's see here. I guess that kind of makes some sense. It doesn't have a huge magnitude in the y direction. And then again, it needs to be offsetting some of the other loads in the y direction. So it makes sense in some ways that it needs to be greater, and we see that indeed is the case. In fact, it's surprisingly significantly greater, but again, it's hard with these complex geometries to really understand where the loads are being carried in the structure.